Oh, hold on.
Yeah, it's before the E1 end of transaction 1. Last step. No, no, no.
No. This one
Yeah,
is
this one.
right?
So what about this transaction? Because E1 ends.
Oh yeah, hold on. This one is that's I think I may have the mistake. TI is older than TJ, then TI allowed to wait. TI is younger than. So this time. So this time the transaction 3 is averted and transaction 1 requests the write block. It may cause the complete situation. So that it is waiting. This is waiting. So E1 cannot be done. Okay? E1 cannot be done. Then you can forward to the next one. R2 read transaction 2 read the data item X. It doesn't cause the conflict. Okay. Then the transaction 2 write on data item X. That's the problem. Right? I think there's something wrong in my wait die algorithm. It's not always the causing the, but that doesn't make sense. Oh, I see. It's not the, we don't have to restrict to the transaction that caused the conflict situation. We have two transactions, so we can decide which one is younger and which one is older. And younger will wait, and that makes sense. If we need, if we leave the one transaction to wait another, it may eventually cause a problem. We need to decide one of them as a victim, right? Then that may not cause a problem. Okay, so in the wait die or und wait algorithm, please excuse me because of the title. I'm not 100% the condition. Let me clarify. We need to decide the victim anyway during the conflict situation because we don't want to enter the deadlock situation, right? So during the complex situation, we have two transactions. They are accessing the same item. Okay. At that time, we need to decide anyway victim. Okay. How to decide the victim? Using the timestamp. So if you kill the transaction, that is the old one, that is a wait die algorithm. Either wait or die. Okay. So older one will keep waiting, and younger one will die. The wound wait or wound die.
What's that?
The wound wait is the opposite. The older one will be die, and the younger one will wait. So in this case, so in this case, this one caused before that. That's the transaction 3. So transaction 3 redraw on data item Z, and the redraw transaction 1 data item Y, and W. The transaction 2 write lock on data item 1. That caused the conflict situation, right, between 2 and 3. So younger one will be aborted, and the older one will wait, right? So that is a wait die algorithm. Then which one is the younger one? This is a younger one, right? This one will be terminated. So T3, and T3. So this one will be terminated and 2. Then W1 requests the write lock. So at the time, this one and this one cause the conflict situation. So 1 is older than the T2, right? 1, 2, 3. So this one, T2 will be terminated. Then T1 will be successfully terminated without abortion. Okay? So that makes sense. Yes.
W2Y and right 1Y. I mean, they're the same operation, right?
This
the
one?
same transaction, yeah.
Yes. This one transaction 2 requests the write lock on data item 1, which is held by transaction 3. So this one and this one, if you take a look at this, just share the item, same item, and different transaction, and one writing. It's a conflict situation. We need to decide one of them as a victim. Which one is a victim? Younger one will be victim. So younger one is a T3, so T3 will be terminated, the abort. Okay? Then moving the next operation, this is aborted, and T1 request write lock on data item Y. Okay? Then that is held by the transaction 2. Write lock, both of them are write lock, so it's a conflict situation. So we need to decide one of them as a victim. How to decide a victim? Who caused, either not caused, who is younger, who is older. So younger is the T2. T2 will be terminated. Okay? Not to enter. It's a better, more conservative. You need to get the holder lock. However, that all the other transactions should wait. The basic is allow and release. However, that may cause a problem. This is a strict version of the basic. Okay? So, in case the conflict situation, we will terminate one of the transactions. Not terminate, abort one of the transactions. How to determine who is younger transaction? So, younger will be the terminated. So that is based on wait die algorithm. But if you are using the wound wait, it's the opposite. The older transaction will be aborted. Then the younger will wait the next one. Okay, so that is the two-phase locking. However, this is a yes.
So if any
Mhm.
in the wait state, and it's like a transaction one is waiting
Mhm.
for some item.
Mhm.
In the next step, it's going to be this transaction going to be end.
Mhm.
So what is the final state of that transaction? If it ends, still one transaction is waiting.
But if you are waiting, so if you are waiting means doesn't mean waiting the item. You can, because the other transaction is terminated. You can get the item. So it's not actually the waiting. It will eventually get the item once the other transaction is terminated. Okay. So this is a two-phase locking algorithm. However, think about the as I said at the beginning of the class, the current modern DBMS system actually allows any transaction who want to write the data, they can write the data. Also, any transaction who want to read the data, they can read the data, which means never terminated, right? How can we implement such a thing? So at that time, we can consider multi-version concurrency control technique. So let me introduce a very interesting story. What is this?
Computer.
Computer. How did you know that? How do you know
Because
that?
I know you.
This is a computer. So in the computer we have, this is a operating system. So operating system manage processes and file system. One more. Who are taking the operating system class? There might be. So process management and file system management. Memory. Okay, computer. Modern computer architecture include such a processor that process the instruction. They are in the process. Okay, that's the process management and file system management, as well as such a memory management. It's a cache area. Why do we need a memory? Why? It's a speed up to access the data. Processor is very fast. Hard disk drive is slow, so we can use the memory, the cache area for the memory. So this is the overall our computer architecture. Then this is your laptop. So using SQL Plus, we can log on the Oracle server. What happened when you connect the Oracle database? You can double click the SQL Plus and username and password. Do you remember there's another one? Username, password, and username, password. There's another one. It's a database name. Network or sometimes database connect string, which means you don't know where you can connect. So there might be some configuration file. In Oracle, it's called the TNS names.ora file. It's nothing but what? Network protocol. Okay, whether you are using TCP or the UDP or the any other. And when you are doing the socket program, what what information do you need?
IP address.
IP or host name, port number. Okay? Then authentication. So these are the very basic socket program. The database connection is based on such a TCP/IP, the socket program. So you need to provide such information where this configuration file is set up by the database connection string. Default is ORCL in Oracle, but depending on the DBMS, it may be different interface, basically same thing. Sometimes in one server, you may have the many database instances. So you need to provide database name. That is the reason that somebody believes that it's a database name. Okay? So this connection string sometimes represented by the database. Then you can connect the database. Then when you connect the database, what happens? This is a client server environment. Client program, server program. And server side, it has a service program that is called listener, like a web server in web service. So there is a server listener program that can create the process for your database connection. Then finally you can access the database. So you select from employee where ID is equal to 111. For example, the major. It will be processed. Do you remember parsing and validation and scanning validation? It is database language, programming language. It should be parsed, should be compiled. However, in such a SQL Plus, it will be compiled as what? Interpreter, like the command line interface. That is the interpreter. Then this SQL will be submitted and processed by the query optimizer and find the best path that you are implementing in your project B. Okay, page 2. So, and finally you got the data. It's a major CS. Okay, we copy the data into the memory. Why? Because next time, if this one is request again, we don't have to access the hard disk drive again. Instead, the data in the memory will be returned. Okay, so this is the general, the procedure, how your submitted query is processed. Then the next one is update. The employee major is equal to CE. Okay? Then this one will be changing. According to the two-phase locking, you need to get the lock. Read lock, then write lock. Upgrade to the write lock and update it. Write the data. Until you commit or abort or the rollback, it's a lock. So if there is another user who needs to access this data, you need to decide who will be younger, who will be the older, because it's a conflict situation. This one is younger, so maybe terminate the over. Not fair. So the multi-version concurrency control means when you update the data, you can always copy. Okay? Then update into CE. This one is older, this one is new. This one is dirty buffer. This one is a changing. It's called this one is a dirty buffer, the new one. Okay? Until this one commit the change. Until this time, another transaction will not be aborted. Okay? Instead, it can access all the version, before version of the memory buffer. This is called multi-version concurrency control. Is it better than two-phase locking. Two-phase locking, you always decide one of the transaction who caused the conflict will be die. Okay, but here you don't have to die. Instead, you can manage before or after. Problem? What if you update millions of data? You need to keep all millions of before and after image. Okay, it's a waste of the memory. However, because of this one, you don't have to terminate, kill other. Okay, you don't have to restart the transaction. Instead, many. If we have any other, you can support them. Also, that multi-version the concurrency control can address the problem of the I forgot the name of that. I explained the one of the problem of the concurrency control is a snapshot to all, which means while you are reading a lot of data, what if the data is the updated? So you need to read the data at a certain time. How can we preserve? This one using by accessing this old the buffer image, old data image. Okay, this is called multi-version concurrency control. Okay. However, at the time, it requires a lot of the research for the memory. That is the reason when you install the Oracle database system, it requires almost half of the 2 GB at least the memory size to support such a multi-version concurrency control. Okay, so we have a little bit more on the concurrency control. I'm going to finalize on the Thursday. Then probably we have a time little bit. I'd like to summarize the second part of the semester. And after that, you can prepare your final exam. Any question? Okay, thank you, and see you on Thursday.